Namaste. Today's presentation is about significance of urine formation. Urine is formed regularly and it is an important part of our day-to-day life. And so many times or always we have never bothered about formation of urine, how it is formed or what is its significance. Today we'll learn about the process of urine formation and its significance. Actually, urine is formed as an integral part of homeostasis. Homeostasis means maintenance of a constant volume and composition of body fluids. Composition means whatever that is there in the body fluids. Usually we refer to the electrolytes that are there and other components that are there in the body. They have to be maintained uniformly, and in order to maintain that, urine formation is very essential. If it is not forming, it can create problems. The entire body volume can change. Today you are fat, tomorrow you are thin. That kind of thing cannot happen at all. Now, how urine is formed? All of us know that urine formation happens in the kidneys. We have two kidneys. Okay, the body weight of the kidneys, rather the weight of the kidneys is 0.4% of the body weight. 0.4% of the body weight is the weight of the kidneys, whereas 25 to 30% of the cardiac output goes to the kidneys. That itself tells you the significance of kidneys. 25 to 30% of blood goes to the kidneys, and that is where this unique, sophisticated process of filtration happens. This filtration happens in the kidneys, and the functional unit of kidneys is what is called as nephron. So the actual filtration happens in the nephron, and about 1.5 millions of nephrons are present in each kidney. Now we have to know about the structure of nephron in order to know the process of formation of urine. Urine comes into the renal system, it comes into the kidneys, and in the kidneys there are nephrons. 1.5 million nephrons means you can imagine the size of the nephron, and all these are actually the rather this is the apparatus where the filtration of blood happens. Now we will look at the structure of nephron. The starting point is like a funnel, or you can call it as a cup. It is called as corpuscle. Okay, or if you can imagine a lotus. Okay, lotus is there, and then it has got a long stem. That stem, then if you bend it, okay, and take it like this. Okay, my purpose is not to write anything or not to make this a regular teaching class. That is why we are trying to imagine all these things. Okay, so there is the lotus part, then there is a stem. You bend it, then take it up, and it is convoluted at the end, and there is a collecting tubule. So what are the portions that are there here near the starting point, the corpuscle where it is there? There also convolutions are there. This is called as proximal convoluted tubule. Proximal, nearer convoluted tubule. Then there is a bend. Then this is called as loop of Henle. Then thick ascending loop of Henle. This is the second part. Then distal convoluted tubule, third portion, and fourth portion is the collecting tubule. Now these are the four anatomical sites of nephron where the actual exchange of ions takes place. Actually, it is the reabsorption of sodium ions. Actually, what are the things that are reabsorbed are sodium, Na plus, Cl minus, K plus, HCO3 minus, some amount of glucose, urea, all these things are absorbed. And along with this, equivalent amount of water also will come. So actually in the urine formation, what happens is 99% of water is reabsorbed, and this is the reabsorption process. Now in case there is a problem in our system which leads to deposition of or collection of excess cellular fluid in our body, it can be found out by pressing your finger on that part. It will leave a depression indicating that there is edema, that is edematous fluid is there. So now we know that we can use or interfere with this process of urine formation by using compounds which can uh, inhibit the reabsorption of sodium at these four different sites. That means if sodium reabsorption is inhibited somehow at four anatomical sites, one is proximal convoluted tubule, thick ascending loop of Henle, distal convoluted tubule, and the last one is collecting tubule or collecting duct, it is called as. These are the four portions in each nephron where the ion exchange takes place, and most of it is the reabsorption of sodium ions. So because sodium ions are reabsorbed, along with that equivalent amount of water is absorbed, and I have already told you what are the things that are absorbed and what are the things that are not absorbed are these drug metabolites, glucose, urea, they are gone, and there are these are excreted, and there are secretions. Secretions are the metabolites or drugs that we take or any other metabolic product that is there are also secreted. These are the things that are happening in the nephrons, but we will require to need only about the sodium reabsorption. So, what are the clinical conditions where now these compounds which interfere with the reabsorption of sodium at the four anatomical sites of nephrons are called as diuretics. That means they induce urine formation. Rather, diuretics are the compounds which increase the rate of urine formation. They increase the rate of urine formation. The amount of urine that is formed will be more. So what happens if there is excess cellular fluid? It goes through the urine, it goes out, so that the edema is gone. Now, where are the conditions wherein this edema will happen? First one is CHF, congestive heart failure. We have said that 20 to 25% of the cardiac output goes to the kidneys. In congestive heart failure, what happens is heart is not able to maintain regular blood supply to the kidneys. That is when what happens, the filtration process doesn't change according to the blood flow, and more amount of reabsorption of sodium happens, and along with that water also is reabsorbed, and that leads to edema. Then toxemia of pregnancy, premenstrual tension, ascites, and there are so many other conditions which lead to edematous condition, and these have to be tackled. Otherwise, we know what problem it can create. It can create problems starting from the blood pressure to impact on all the other organs. If there is more amount of fluid in our body, homeostasis means if we are healthy, always uniform composition and volume of fluids is maintained in our body. So now, after having learnt this and saluting those scientists who found out that these are the four anatomical parts of nephrons where the actual reabsorption takes place, and this is where we can interfere with the reabsorption and we can bring in diuresis. Otherwise, there is no other way you can take out the extracellular fluid or the edematous fluid that is there in our body. How else can you remove it? It can be removed only by interfering with the process of urine formation, or in other words, in those four anatomical sites where reabsorption of sodium takes place. If you inhibit that, then diuresis will happen. The first site is the proximal convoluted tubule, and there are two compounds. Mainly, these names also I am mentioning because of the feedback that I have got. Acetazolamide and methazolamide. These are the two compounds which interfere with the sodium reabsorption at site 1. So if the sodium reabsorption is inhibited, that means sodium is not reabsorbed. So that much water doesn't go and sodium comes down in the tubule. Okay, there is a descending limb, then ascending, thick ascending limb is the second site. Now, depending upon how much of reabsorption takes place, the efficacy of the compounds is decided. There are only two compounds. So, in other words, what we can learn is there are millions of compounds, and people synthesize again millions of organic compounds on a day-to-day basis, and only two compounds. That means you can imagine what amount of work must have gone into finding out these compounds which have rigid, rather these sites, these analytical sites have rigid structural requirements. Not everything can act as a diuretic. So these are the two compounds. Next, what happens is the total efficacy of a diuretic is based on its intrinsic efficacy, where it acts at a particular site, and downstream what happens is what is important. So at the site, first site, whatever reabsorption has taken place, then what happens, the fluid that comes down the tubule, the download that is there, it is there at site 2, that is thick ascending limb. It is called as loop of Henle. The compounds which act at this site are called as high ceiling diuretics. What could be the reason? Because the maximum reabsorption of sodium takes place at this place only. So whatever reabsorption has been inhibited at site 1, still whatever that is there in the download again can be reabsorbed at second site. So here those compounds which inhibit the reabsorption of sodium at this site, that is thick ascending limb, are called as high ceiling diuretics or loop diuretics. Here there are two compounds, furosemide and ethacrylic acid. These are called as high ceiling diuretics. Next is, we have already considered third anatomic site is there, that is distal convoluted tubule. Here thiazides and thiazide like compounds act as diuretics. So now whatever that has come down, it goes to the third site. Here only 5 to 8% of sodium reabsorption takes place. So these compounds will not be all that efficacious. And usually thiazides and thiazide like compounds, chlorthalidone, thiazide, benzthiazide, these are the compounds which act as diuretics, and their site of action is site 3. And but these compounds, they cause what is called as hypokalemia. Hypokalemia means uh, potassium level is decreased. Because potassium loss is there, potassium level is decreased in our system, and it adds or increases the toxicity of cardiac glycosides. So if somebody is having congestive heart failure, naturally he will be prescribed the glycosides, cardiac glycosides. So if you are giving cardiac glycosides, and naturally diuretics have to be given, so at that time you have to be careful that there is no potassium loss. If hypokalemia occurs, then what will happen? It will increase the toxicity of cardiac glycosides. So the usually for site 2 as well as site 3 diuretics, along with this potassium sparing diuretics are given, and these act at site 4. That means at site 4 there is sodium potassium exchange. So if you inhibit the reabsorption of sodium at site 4, it will inhibit the loss of potassium. There is no potassium. These are called as potassium sparing diuretics. And here actually there are two types of compounds that are there. One is aldosterone inhibitor. So aldosterone is there in our system. Aldosterone is a steroidal compound. Okay, steroid means, in order to know for general public, for example, we all know about cholesterol. Cholesterol is a steroidal compound, and sex hormones are also steroidal in nature, and aldosterone also is a steroid. So in order to inhibit aldosterone, you have to have another steroid which can competitively inhibit aldosterone, which is responsible for reabsorption at site 4, and the compound that is used is spironolactone. And because of its structure, it has got overlapping hormonal activity. So some sex hormone type activity also will be there. So what happens is, instead of spironolactone, we have to find out some other compound which doesn't have overlapping hormonal activity, and these compounds are triamterene is there, and amiloride. These are the two compounds which also inhibit reabsorption of sodium at site 4, but the mechanism is they inhibit the electrogenic reabsorption that happens at site 4 is inhibited by these compounds. And these compounds, the sodium reabsorption that happens at the distal, at the collecting tubule, this is the fourth anatomical site, is only 2 to 3%. So they are not that efficacious. They are very poor diuretics, and usually they are given in combination with site 2 and site 3 diuretics. And in order to avoid the potassium loss, usually these are given along with site 2 and site 3 diuretics. So this is how urine formation can be interfered with, and whenever there is any problem or edema due to any reason, that can be countered by using the particular inhibitors. So site 1, site 2, site 1 is the convoluted tubule, proximal convoluted tubule. Site 2 is the thick ascending limb of Henle. Third is distal convoluted tubule. Fourth is collecting tubule. So a combination of these can be used, and we can control the urine formation in such a way that a person is able to lead a normal life, or you can at least avoid the problems that can arise due to edema because of improper filtration. Now there is one more thing. There is what is called as diabetes insipidus. Diabetes insipidus also causes excess urination, and because of the loss of urine that is there, it also increases thirst, and it has got nothing to do with diabetes mellitus, which is related to sugar. It is not that at all. And diabetes insipidus is caused due to a hormonal deficiency, because of the deficiency of anti-diuretic hormone. That name itself tells you, anti-diuretic hormone deficiency. If it is there, only then you will have diabetes insipidus. But the not many people suffer from diabetes insipidus, and even in that case, diuretics are used with advantage. I hope I have made things clear. Namaste.